crazy quiet.
Yes. Okay, well, that's the first
Make sure we're on the same one. Okay.
Aren't you supposed to work it out?
Yes, you're supposed to work it out. Without a calculator.
They're like,
Better you get freaked out now than freaked out May 7th. That's what I tell mine. If you're gonna lose it, let's lose it today. Good, then you're right on track. I decided to turn the boat and aim it at a cliff, and y'all are getting scared.
Yes,
All right, you got 20 seconds?
You'll do fine. Y'all do fine. You'll survive. Juana's gonna get y'all prepared. Right? You won't die.
Wait, there's 14? No, no, whoa. Whoa.
You are gonna do 4 as well, but, because it also has to do with that question. But I didn't pay you that yet, so. I've only asked you to do
I
2
said
and
the
3.
boat can't work.
I just
Go ahead.
see. Just like those rules.
All right, time's up. This question was number 1 on the exam in 2015. Now, what's it supposed to do? It's supposed to make you want to change your underwear. I mean, this question was. If the question scares you and you don't know what's going on, I would totally not do this question. You asked, are we supposed to work this out? Are you supposed to work it? Yes, you are. If you can't, did you even look at number 3? Or have you spent all your time on number 2? You gotta at least look at 3, okay? So, look at 3 real quick. What happens to the nitrate ions in that equation? You have an unknown metal, and then you add silver nitrate solution, and you make a precipitate of the unknown metal chloride. What do you call an ion that does nothing? A spectator ion. This is not a stoichiometry problem, ladies and gentlemen. This is a, do you understand in a reaction what happens? They just bundled it together with a stoichiometry problem. So what did y'all get if you looked at number 3? What did you get for number 3? D. They remain dissolved. You've got nothing but, it's just a spectator. It's just sitting there watching. Turn the page. Number 4. We'll come back to 2. Let me draw the boat. Who doesn't love a pitcher? Everybody loves a pitcher. Which one best represents the silver nitrate solution before the reaction occurs?
White guy. Yes. Okay, I can see.
Can y'all tell me what ain't the answer? Pick out one that you know ain't it. Can't be it. C. Why not?
There's too many.
The head part of the Mickey Mouse, the big circle part, has a negative charge for what? It's facing the positive ion and it's facing the negative ion. Can't have that. You know that positives like to hang out with negatives. So that's not possible. You got another one that can't possibly be it.
B.
B?
No. B. No, my bad. No. Whoa. D.
D?
No. I don't know what we're doing.
Alright. So it's okay. Alright, what's wrong with D?
Reaction. Because that's what I was thinking.
They're stuck together. And we know in a solution those ions dissociate. Right? So, we got rid of this one, we got rid of this one. What's the difference between these two?
The way
Which one is it?
Which way the Mickey Mouse's face? So, the ears of the Mickey Mouse have a positive charge. How would they feel about the positive charge of the silver?
They don't know.
They would not like each other, because positives and positives repel each other. So the answer here is A.
See, look, I was just like clearing the path a whole lot faster.
Thank you. Yeah, you're just calling out answers and then saying no. I wouldn't call that clearing the path. I would call that stirring up muddy water.
The bug
Okay.
got stuck for a little bit.
Oh, hold on, I'm affecting you negatively. Go.
All right, now, realize that they asked you 3 questions on one data set. And you got 2 of the 3 questions right. To get half the questions on an AP exam means you're getting about half the possible points, means you get a 3 on the exam. So you have to be okay. If you're the person that has to get everything right, you have to give that up now. You have to turn that over to a higher power, because you are not going to get everything right. But if you can get 2 out of the 3 questions right, then you're golden. So let's look at how you would do this. Can y'all tell me how much the AGCL weighs? Just the AGCL.
1.43.
1.43 grams. Because this is with the piece of filter paper, that's just a piece of filter paper. So it weighs 1.43 grams. Lovely to see. What is the molar mass of silver chloride? 143 grams per mole, which means you have 0.01 moles, because it's 1.43 divided by 143. Well, if you have 0.01 moles of silver chloride, how many moles of chloride do you have? If you have 0.01 moles if you have 0.01 moles of silver chloride, how many moles of just chloride were represented in your sample? 0.01. Because 1 mole of silver chloride will give off 0.01 moles of chlorine, right? So can you figure out what 0.01 moles of chlorine weighs? Well, chlorine weighs 35.45 according to your periodic table. So what would 0.01 moles of chlorine weigh? 0.35 grams. While the mass of the whole thing is 0.74. And chlorine is 0.35 of that. So how much is the metal? If the chlorine's 0.35 and the whole thing weighs 0.74, how much is the metal? 0.39. Now, these are your choices. Sodium, potassium, 1 potassium, copper, and lithium. Which one looks like a 39? Which one looks like 0.39 on your?
A.
Na is 22.99. I mean, the molar mass of sodium is 22.99. What looks like that 0.39 on the periodic table? Potassium. And so the correct answer there is B. And ladies and gentlemen, that is a, do you make a 4 or do you make a 5 on the test? On a multiple choice question where you don't get a calculator, trust me, that's a hard question. Okay? So, could you have worked that? Yes. But it's not necessary to. So, y'all look at number 5 real quick, and here's something I want y'all to notice about an AP exam. What is above question 5, above this equation 5H2O2? A line. That tells you that we are done with that description of you mixed a metal with silver nitrate and blah, 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 blah. Okay? What do you notice about the question itself? Right? It's really long. It's a lot of reading. The AP exam is turned into a lot of reading. And half your issue is going to be figuring out what is the dang question asking, really? So let's see if we can pick this one apart. All this gobbledygook is great. Life is great. blah, 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 blah. The rate of appearance of O2 was 1 times 10 to the negative third. What was the rate of disappearance of permanganate? When y'all get into kinetics, you're going to hear rate, you're going to think, this is a kinetics problem. It's not a kinetics problem. For every 5 O2s, how many permanganates are disappearing? For every 5 of these that show up, how many permanganates are disappearing? 2. It's a 2 to 5 ratio. So if the O2 is appearing at 1 times 10 to the negative third, then all you would have to do is don't worry about this middle part. This has nothing to do with it. They're just asking you from a simple stoichiometry standpoint, if this is showing up at this rate, and look, using your balanced equation, can you do something like this? That's all you're doing. You're looking at that ratio of 2 to 5. You're not getting scared about it. You're not worried about changing underwear anymore. It's a simple problem. But a lot of y'all are going to read this and just get tired on the second line and go, no. Keep going through. So, correct answer there is D. And y'all can, it's a 2 to 5 ratio. I know it's hard to see where we're at, but it's a 2 to 5 ratio, and so you can do that math. Now, also keep in mind here, they have both 4 times 10 to the negative third and 4 times 10 to the negative fourth. Very similar answers, and the correct answer was 4 times 10 to the negative fourth, because you're taking 1 times 10 to the negative third times 2 divided by 5, all in your head. So again, teachers, mental math, this would be a good bell ringer this week, kind of a thing. Can you just do this math? Just to keep that sharp. All right? Number 6, minute and a half, go. Turn and talk.